Hello. So today we are going to discuss about software as a service, SaaS, and distributed version control system. In SaaS, we will take example of Facebook testing, Infern, and Spinies. Facebook is one of the top most very popular software as a service that almost everyone of us had used. How this Facebook undergoes testing, so we'll discuss this. Then distributed version control system, we will study very popular repository of code bases and libraries, that is GitHub, and how this Git large file system manages. Then this Infern, in this Facebook testing, there are four topics that we'll study: Infern, Spinies, FBLearner, Facebook's OneWorld platform. So in scalable Facebook testing, what it does scaling for large number of uh, dimensions. Means there could be multiple dimensions for large number of customers. So there could be different techniques that are required to be tested on different dimensions that might fail in one dimension but not fail in another. So this scalability needed to access the degree of deployability. So there's for large number of customer, their need of scalability that can access and do the processing for the large number of applications uh, to be tested. So this the challenge, and there's both challenge and opportunity related to analysis of scale. So this static analysis could be done, dynamic analysis could be done. So this both things could be analyzed. Then this Facebook deployed two technologies which we will study. First one is Infern for static analysis. Second one is Spinies for dynamic analysis. Then these both are the research-based startup that subsequently become deployed for the mass scale, and there's lots of people who can use it, who are basically using indirectly these applications. So how they are means Facebook is using this Infern and Spinish for testing purpose. So it basically indirectly affected billions of people across the world. And first topic is Infern, is for static analysis at scale. How this Infern works, it is basically deep static analysis, which is built on Java, Objective C, and C++ code base. It could test, means Infern could do deep analysis, deep static analysis on Java, Objective C, and C++ code bases. Then Infern at Facebook, basically it was acquired in 2013 from a startup named as Monode. So this startup has been acquired by Facebook to acquire this Infern. So Infern is one of the open source and which is used by several of companies like AWS, Mozilla, JD.com, Spotify. Then this it is based on fundamentals of separation logic that can do scalable algorithm testing, and that helps reasoning that state transfer from one state to another. So what are the data structure it stores? Like it stores heap for memory, then the local or the stack. So these variables are being tested, and then dynamic allocations could be tested. Then this is based implemented as a compositional program analysis. What is that compositional program analysis? Like inter-procedural analysis. One procedure is calling another procedure, and another procedure is calling third, fourth procedure, fifth procedure. So this is analyzing these multiple connected procedures is inter-procedural analysis. Then basically this is Infern follows pointer chain that for the safety of program with embedded pointers. These are basically technical terms of software analysis, software engineering, program analysis. So we'll not go in much detail of these. So these are the technical things behind this Infern. This is the scale to the it basically scales means it could do testing for large code databases. Then what are the results? The results are like Infern can find tens to thousands of bugs that could be fixed by Facebook developer before it goes to the production phase. Production phase means a final phase which could be used by the users. This basically Infern detects tens to thousands of bugs for fixing. Then this Infern is basically do what continuous integration. So this continuous development and deployment is one of the Facebook practice. What does it mean by continuous integration? So whichever new codes and new functionality keep on coming without stopping the main functional main app, it keeps on adding these functionality to the app. Means update happens in the Google Play stores like this. So basically how this backend testing happens. So in the backend, the differencing would be analyzed. What is the code differences? And then the code differences are being undergo a review process. So these all the codes that are having differences. So these means what are the differences means new code and the old code. So these codes are reviewed. Then developer basically shares single code base to alter and commit. This developer basically shares single code base for alter and commit. Then basically the developer prepares diff, diffs and submits for code review. So this developer basically shares a single code base, one code base where everything alteration and commit could take place. Then this prepares the diff file after this code differencing happens. So this differencing file would come up and this file goes for review purpose. Then this infern basically runs as a bot during diff time. How it runs? This diff infern basically runs as bot during diff time. So this Infern has having the code that can be automatically running, and then it basically writes what comments for the developer. Automatically, it writes comments for the developer and for human review. Then at the post land is the final continuous integration part that incorporate the master build of the system. So the code review is where the humans are being involved, and this diff is being done by the infern, and this commenting would be done by the infern. So code review will be done by the human. That will be helped by the infern. The next Spinach, which is dynamic analysis at scale. So Spinach is basically deployed to run continuously, means it keeps on doing testing. The test cases it has, so test cases is correct or not correct, how they are. So this testing takes place in the infant. Then you can have another feature of this spinach is multi-objective automated test case generation. So this multiple automated test cases are being generated, and these basically seeks to find out maximum fault. And this spinach try to do minimization of debugging effort and error that are required to be fixed. So this spinach is basically used for continuous testing and for the internal builds of Facebook app. And then this spinach is also used is based on multi-objective automated test case designing, and that faults are being detected and the debugs are being minimized. Then this spinach basically uses FBLearner. What is FBLearner? We'll see in the next slides. This Facebook machine learning infrastructure is said to be FBLearner. And there's Facebook's OneWorld platform, which actually provides large amount of uh, devices, artificial devices that actually simulates the original Facebook like a user. So we'll discuss that. So this spinach is basically based upon FBLearner. What is that FBLearner? Is Facebook machine learning infrastructure. What it does, machine learning, this FBLearner performs ML machine learning at large scale. How it performs, it basically has huge infrastructure, and there are various phases of execution, and tens of trillion days it could execute and perform. Then this FB learner basically has is a type of ML platform that are designed for supporting global scale. Means it can support thousands and not thousands but billions of users of Facebook. This amount would be supported by FP Learner. Then Spinach is from ones to thousands or ones to hundreds of service deployed. So basically, Spinach test one to hundreds of services that are deployed on FP Learner. So this Spinach is one of them which uses FP Learner. So FP Learner is being used by many services of Facebook, and Spinach is one of the application which uses FB Learner. Then this FB Learner basically have flow of component in the Spinach. So FBLearner basically have this flow, these three things it do for the spinach. So basically what it does, it deploys and detects crashing behavior in that directly into the workflow. So this FBLearner detects what? Crashing behavior. Then after deployment of this thing feature, this it's integrate with the fabricator for report generation and action for fixing the bugs. So this FB learner helps in that for fabrication of report and then action for the fixing bugs. Then it corrects the failure detected. Thereafter, FB learner has to correct the failure whenever the failure is detected. Then Facebook's One World platform. What is Facebook One World platform? It is basically supports scalable deployment at large scale. There could be many emulators that are possible at a time. So means thousands of emulators or which are mimicking means user. So these are artificial emulators and they are mimicking thousands of users. So this Spinach basically deploys what? Thousands of emulators to test the Android app alone. So this is part of Facebook's One World platform. We'll discuss this Facebook One World platform also in detail for emulating purpose. So this is FB Learner that we will discuss in detail. Like FB Learner is, you can assume machine learning as a service inside Facebook. So it is simply said as machine learning as a service inside Facebook. So as is FB Learner. What it does these component feature storing, FB learning flow, then FB Learner prediction. So this storage, feature storage, flow analysis, and prediction. And what is the model of this? So various likes, comment, and share are the various options in the Facebook app. So it collects data from that, and this data is extracted as features. What are the comments? Where it is being shared? How many likes are there? What are the type of likes? So this FB Learner basically stores this features, and then it goes to the training phase. And FB learner basically do the training and it generates model, and this model will be generated as inferences. So there's various inferences like prediction graph are being plotted, and again this with the prediction it goes to the Facebook app means how to work out. So this is a cycle, you can say. Then what are the machine learning algorithms that are being used by various products and services of Facebook? So this SVM support vector machine, gradient boost, decision tree, multi-layer perceptron, convolution neural network, recurrent neural network. So this SVM is used by the Facer service for matching user, and this GBDT is being used by Sigma service of Facebook. MLP is being used by ad and news feeds, the search engine, Sigma. Then CNN is being used by the Facer for feature extraction and Lumus service. So we'll not go in detail of these services and these algorithms. It's just for mapping purpose. This RNN is used by the text analysis for understanding translation of speech recognition. It could do so this. So these are the models of machine learning, and these are the services of Facebook that uses these models. Then next, we'll discuss Facebook OneWorld platform. What is Facebook OneWorld platform? It basically supports some standard communication mechanism like Android debugging bridge. So what is AADB? It's like a artificial emulator that you can run on the laptop, which makes like a mobile phone. But why you run this emulator? To test and debug the Android app that you are developing. So you keep on developing that app on your laptop and machine, and then on the same machine and the laptop, you can have that emulator ADB for testing purpose. Similarly, this Facebook One World has thousands of such emulators working, and that actually provide illusion that there are thousands of remote devices that are uh, actually they are present in locally, but they behave and mimics like these thousands of emulators are remotely, so they can do the testing. Then what are the runtime worker service? So this runtime worker service says that it basically manages life cycle of resources and responds to the request of from client to use its resources. So this runtime worker service it basically manages what a life cycle of resources. What are the life cycle of resources? How these engines are being created? How these apps are being created? How they can be responded and that could be used. So the request from client could be used and this resource could be done. Then this one world daemon is there where it basically connects to remote resources. One world daemon, what it does, so it basically connects uh, resources with the protocol to communicate with worker and set up the environment. So one world daemon basically set up an artificial environment and artificial remote look resources that are being required by the protocol to communicate. So these resources, mimicking these resources and workers and setup of the whole environment is being done by one world daemon. Then there's scheduler. So this it's a it uses Jupyter. So this scheduler is basically for the job scheduling service at Facebook to match the client with worker resource as per the specific requirement. So there's resources which will be mimicked by one world daemon. Now this job scheduling that these are the requests, these should be the response. Who will do this? It will be done by the scheduler. So this scheduling of job request to the Facebook app will be done by the scheduler, and it basically try to mimic and match client worker resource as per the specified requirement. Then satellite basically what it does, it basically it connects the local resources to the global one world platform. So so that this satellite would work like a client which is sitting at infinite so distance, means very far from that Facebook server. So it basically satellite try to mimic the distance between client and Facebook server. So this is the workflow of Spin, is how it do automated test case designing and testing. So basically source code and APK of Facebook is being sent, and there's multi-level instrumenter and decompiler takes place, which generates instrumented APK application. So this decompiler basically do static analysis of the strings, and with this whole thing, they will create what, a database with Android device state logger, means the state in which it has to be transferred, and these strings, static strings. With all these things, they create an intermediate database, and they find out the various types of fitness extractor with the genetic algorithm. So they find out various type of test cases. They generate various kinds of test cases, and they do the testing, execution, replay, keep on running those with some gene interpreter, means there's genetic algorithm is a specific uh, field of machine learning, artificial intelligence. So this actually helps to generate the artificial test cases, and that test cases would be executed. And when it executes the test case, the reports are being generated. So these reports are being, you can replay the video how the execution of testing has been done. You can see the coverage of report. You can see what are the crashes happened because of these test cases. Then ultimate purpose of all these things is to generate test suits. So this test suite basically contains various kinds of test cases. These test cases could be run with the help of the spinnies, and then test cases could be run and seen which test cases are passed and which test cases are failed in the report. So these things, this is the architecture for this Spinny's automated test design and workflow. So thanks. In next part, we'll discuss distributed version control system. Okay, bye.